Have you ever wondered what happens to matter when something burns, explodes, or changes form? Does it just vanish into thin air? Or does it go somewhere? Today, we are talking about one of the most fundamental and mind-blowing concepts in all of science, the law of conservation of mass energy. It's a principle that links chemistry, physics, and even the universe itself, and it all starts with understanding what mass and energy really are. Mass is the amount of matter in an object, the stuff that makes up everything you see and touch. From your phone to your breakfast to your own body, everything has mass. Energy, on the other hand, is the capacity to do work. That includes motion, heat, electricity, light, sound, any way that one object can affect another. At first glance, mass and energy seem completely different. One is tangible, the other is more abstract. But over time, scientists realized the two are deeply connected. Back in the 18th century, a French scientist named Antoine Lavoisier made a crucial discovery. He found that when he carried out chemical reactions in a closed container, the total mass before and after the reaction was always the same. Burn something? The ash might weigh less, but if you collect all the gases and particles released into the air, the total mass balances out. This became known as the law of conservation of mass. Matter can't be created or destroyed, it just changes form. Meanwhile, in the world of physics, scientists were noticing something similar with energy. Drop a ball and it speeds up. That's potential energy turning into kinetic energy. Light a match, and chemical energy turns into heat and light. Again and again, they saw that energy wasn't disappearing or appearing from nowhere, it was just transforming from one type to another. This gave rise to the law of conservation of energy. Energy, like mass, cannot be created or destroyed. For a while, these were treated as two separate laws, one for mass and one for energy. But everything changed in 1905, when Albert Einstein published a paper that changed our understanding of the universe. In it, he introduced the now famous equation, EmC superscript 2. This simple formula revealed a profound truth: mass and energy are two forms of the same thing. They are interchangeable. That equation means that even a small amount of mass can be converted into an enormous amount of energy, because the speed of light squared, c superscript 2, is a staggeringly huge number. That's why nuclear reactions are so powerful. In both fission, where atoms split, and fusion, where they merge, small amounts of mass disappear, but not really. That mass is transformed into massive amounts of energy. It's how nuclear power plants generate electricity. It's how the sun shines. It's how the most powerful forces in the universe operate. Because of this, the old laws had to be updated. Scientists combined them into one unified idea, the law of conservation of mass energy. It tells us that in a closed system, where no matter or energy can enter or leave, the total amount of mass and energy remains constant. Mass might turn into energy, and energy might form mass, but the total sum never changes. It's like a cosmic bank account, debits and credits can happen, but the total balance remains the same. And here's what's cool: this law isn't just for scientists in lab coats or massive particle colliders. It's happening all around us. When you drive a car, gasoline's chemical energy is converted into motion, sound, and heat. When you eat food, your body turns mass into energy that lets you walk, talk, and think. When a star explodes in space, it scatters both mass and energy across the galaxy, but the total amount never vanishes. It's simply rearranged. Even our modern technologies rely on this principle. Solar panels transform sunlight into electricity. Batteries store chemical energy and release it as electrical power. Rockets convert fuel into kinetic energy to escape Earth's gravity. Every process, every reaction, every change in the universe is governed by this fundamental law. So next time you see something change, whether it's boiling water, a glowing light bulb, or even the sun rising, remember, nothing is really lost. The energy and matter are still there, just in a new form. It's one of the most beautiful truths in all of science. Thanks for watching. If you found this as fascinating as we do, be sure to like the video, subscribe for more science breakdowns, and drop a comment below with your favorite example of mass or energy transformation. Until next time, keep wondering, keep learning, and remember, in the universe, nothing is wasted.